Welcome to my Electrical Lectures channel. In my previous video, we have learnt how to size circuit breakers and overload for different types of loads, especially motors. In this video, we will learn how to calculate cable size, or in other words sizing of cable. As you can see, that as per NEC standard, the size of conductor or cable shall be 125% of full load current. But this is not simple as it looks. It requires some more calculations. First of all, let's see the most important factors to be considered while sizing the cable. Ambient temperature factor, which governs dissipation of heat from cable. Next is grouping factor. Each multi-core cable is one circuit. Group of 3 single-core cables is one circuit. Group factor is selected from the table based on total number of circuits. Next is voltage drop. Always select the size in which total voltage drop shall be less than 5% of rated voltage. Next is short circuit rating. The selected cable shall be capable to withstand maximum short circuit current. Last but not the least is the method of installation. The current carrying capacity of same cable is different for different type of installation. Let's solve one simple example by considering all factors to size the cable. Kindly follow each step. Let's say our load is 150 kilowatts motor. The very first step is to calculate full load current. We will use three-phase power formula. Let's take voltage equals to 400 volts and power factor 0.8. Putting all values, the full load current comes out to be 270 ampere. The next step is to find the load current after applying all correction factors. For this, divide load current by all derating or correction factors. Let's say we take 2 multi-core cables per phase, and an ambient temperature equals to 45 degrees Celsius. For grouping factor, let's refer to the table. Here first select method of installation. In my case, I am using perforated cable tray. Next is to select number of circuits. In our case, since I am using 2 multi-core cables, there are 2 circuits. The value of group factor is 0.88. Next, refer to table for ambient temperature factor. Here you can see a table. Select 45 degrees Celsius. The factor comes out to be 0.79 for PVC cable. Putting all values in the formula, the total load current now become 388 amperes. The next step is to select the cable size from table. First of all, divide the total current by number of circuits. The current comes out to be 194 ampere. Now here you will apply NEC standard, which states that conductor size shall be 125% of rated load. Now multiply load current with 1.25 to get final current, which is 238 ampere. For 238 ampere, we have to select the cable from the table. In this table, first select method of installation. Then comes type of cable you are using. We select multi-core cable. In this column, look for the current, which is either equal or greater than computed load current. 238 ampere is okay. And cable size comes out to be 95 square mm. Next step is to calculate voltage drop of this cable. For this, again refer to voltage drop chart of same cable. Here you can see 495 square mm 3 or 4 core cable. The voltage drop is 0.43 per meter per ampere. Next is to multiply voltage drop with total load current and total length of cable, which in my case is 30 meters. The total voltage drop comes out to be 2.5 volts, which is 0.62% of 400 volts, which is well below 5% limit. So the cable selected is total 2 number 95 square mm 3 or 4 core cable for 150 kilowatt motor. The last step is to refer to short circuit capability table to check the maximum short circuit withstand capability of selected cable size. I hope you understand how to size the cable. For more interesting videos, stay tuned and don't forget to subscribe our channel.